This is the second of 4 videos on TdBench version 7.2, which describes the TdBench scripts and how to run them. So what does it take to run a test? A defined statement which provides the name and title of the test. This also causes a unique run ID to be assigned for the test from Teradata. A queue statement to collect queries to be run into a hold file for the test. A statement that provides one or more workers for the test. In this case, the test will run under the TdBench master login ID. And a statement to kick off the run. TdBench will execute everything that's been queued up and stop. But not all tests are that easy. If you need to run 10 streams of queries, just add a repetition count to the worker statement to say how many you want. When the run statement is processed, a master process will feed the next query from the queue hold file to the next available worker until the queue is empty, and then stop the test. Sometimes the prospect wants us to run a test for some fixed amount of time. In that case, the script is almost the same. Just provide a duration for the test on the run command. For 30 minutes, you could say 30M, or 1800 S for seconds, or 0.5 H for half an hour. When the run statement processes, a process will watch the clock and stop the test at the end of the interval. This is known as a fixed period test. But sometimes even more is needed to model the user environment. This shows a script that defines 2 queues, one for reporting and one for data mining. Each queue gets its own queries and workers. Then you can use TASM to apply different workload settings by profile, account, or username substrings. The examples here show Q1 or Q2 as queue names, but it's merely a label used for a set of Linux files associated with each queue. You could name them light, medium, heavy, or finance, call center, marketing, or any other set of names needed to make the modeling of the user environment clear. When the run statement processes, each queue's workers process independently until the overall time for the run elapses. You run TdBench by executing the tdbench.sh command. You can then execute TdBench commands or Linux commands. If a command isn't recognized by TdBench, it is passed to Linux to execute. You begin the definition of a test run with a define command which gives a name and a title to the test. You type in the queue command. In this case, we're using a sample list of queries in the scripts directory. You enter the worker command. Instead of the login ID, you can use me as an alias for the benchmark control user. You enter the run command, the test executes, and all queued queries are run. When it's complete, the test tracking table is updated, and the logs from the BTK session are zipped up and put into a directory by run ID. The commands can be put into a command file, which can contain one test or a series of tests. To execute the command file, put the name or names of the command files on the tdbench.sh command line. It then runs the command the same way as they ran interactively. When the test is done, the test tracking table is updated, and the logs are saved. There are numerous ways to model the workload using TdBench. You've seen a queue statement where we reference a directory or file specification. You can also enclose a statement in quotes. The statements can either be SQL, executed by BTK, or Linux commands, such as running a script to load data. You can specify a parameter file, and then the quoted statement or queries in a file will be replicated for each line in the parameter file, substituting values from the parameter file into markers in the query. You can specify a time when the OS statement or query should execute, which allows you to kick off loads or killer queries within the period of a test, or even replay the production query arrival. Or you can use the paste command to specify the arrival rate of queries on a queue. Sometimes in a fixed period test with multiple queues, you may not want one queue to repeat since it's doing data loads, so you can put a stop or kill on that queue. Or perhaps you've got a background workload in one queue that you want to repeat, but when the work in the primary queue completes, you want to kill the entire run, so you can queue a kill all on the primary queue. You can build command files with TdBench statements and executing by putting them on the command line of TdBench or use the execute statement to run them. You can use the include statement to reuse common script statements in different tests. TdBench can be run interactively. Any statement that isn't one of the 28 TdBench commands will be executed by Linux. That allows you to view or fix things while developing a script. You can also include Linux commands in a command file to run programs before a test begins. So, for example, you could build a command file that runs tests with 1, 5, 10, 20, 40, and 80 different workers. Then run BT to change the views to point to a database with a larger scale data or one with AGIs, and repeat the tests from 1 to 80 workers. If you develop a script interactively, you can save the commands from that run ID to a file, edit the file, and run it later with the execute command. The normal Linux sleep command allows you to sleep for seconds, minutes, or hours. TdBench overlays that functionality with the ability to specify a time, such as the start of a maintenance window, and the script will pause until that time has arrived. Finally, you can use any of the Linux bash commands to use logic to affect the flow of the script execution. TdBench exposes variables about prior runs and looks for values in the variables go to and skip next to affect the flow of the script. You can even put interactive prompts to get a variable and use that variable in the TdBench commands later in the script.